All right, and hello, and welcome to OneClass. This stream is on trigonometry and pre-calculus. Again, my name is Joey. I'm going to be your math teacher for this session. So just a little bit about myself. Again, I am a intermediate senior secondary school teacher. I'm currently a teacher candidate at York University, just finishing up my last couple of days now with York University, and then I'll be a fully certified teacher. My special subjects, or my primary subjects, I should say, are science, so kind of science and chemistry specifically, and also music. However, I am also planning to get my math teachable further down the road as well. Here in OneClass, what we're aiming to do is we're providing online lessons for particularly secondary level subjects in chemistry and in mathematics, so that if you're currently at home because of the COVID-19 situation, what you can do is you can either catch up on math or you can get ahead in math, so that when you do go back to school, you have those resources ready and you're ready to tackle on the curriculum then. So with that being said, let's jump into today's lesson. Again, today's lesson is going to be on piecewise functions. So let me just do a little review of what we did before, and then we'll go into it. So what we have today is, again, last lesson what we did was we did a lot of work with transformations of functions. So we talked about the following things. We talked about things such as vertical horizontal shift, so moving left and right as a horizontal shift, moving up and down as a vertical shift of a graph. We talked about also horizontal and vertical compression. So we talk about stretching or expanding a function or expanding the graph and compressing a graph as well. And then we talked about reflections along the x-axis. So remember, up and down is reflecting along the x-axis, and the left to right in this case is reflecting along the y-axis there. So we talked about all these things. We talked about 6 different transformations and what we can do. And what we can do now is I'm going to introduce the topic of piecewise functions. We're actually already familiar with this kind of topic here, but we did it more so in terms of algebraically, not graphically. So what we're going to do is I'm going to try my best to graph this. What I'm going to actually probably going to do is I'm going to use Desmos to help me out as well, just because I'm not given kind of graph paper on this program here. So I'm going to do my best to kind of sketch it for you, and we can always check it with our graphing calculator. Unfortunately, I can't edit this PDF document here, which is really unfortunate. So what I'm going to do is I'm going to try to sketch this graph for you and kind of work with that, and then I'll show you the nice and pretty one on Desmos afterwards when I'm done, and hopefully it matches up in terms of what I wrote and what I sketched and what actually happens here. So let me define piecewise functions for those of you who are not familiar with this. So we have here piecewise function. So what is a piecewise function? You can think of this as it's a piece, right? The word piece is in here, which means a piecewise function contains many pieces, or contains two or more pieces. And what's a piece in this case? A piece is actually a function itself. A piece in itself is a function in itself. And what it is if you look at, for example, in question 1 here, you see I have this kind of squiggly line here. So let me define this for you first. So for example, number 1 is f of x equals, and you see this kind of like little squiggly line, and you have minus 2x minus 1, and you have a comma from x, and then you see here x is less than 2, and then you have negative x plus 4, and you have comma says x is greater than 2, right? So what it says here is this function, or the piecewise function, so f of x is the piecewise function here. So this here is the piecewise. I'm going to see piecewise function. And what it is it's separated into 2 parts, because you see here, so I'll show you. So this is part 1. So here's part 1, and this here is part 2 of the piecewise function. So let's see part 1. So part 1 states that it's negative 2x minus 1. So again, it's a linear function, or a linear equation. In this case, this is linear. And it has an exception. Look at the exception here. So this is the little interval here. This here says that it's going to be this function, so negative 2x minus 1, this linear function, if x is equal to or less than 2. So this here states that. I'm going to write that in words for you. So this here is the function is negative 2x minus 1 if x is equal less than or equal to, less than or equal to 2. So that's what it's stating in this first kind of part here. And the second part, if you look here, is negative x plus 4, right? As you can see, this is also a linear function. So let me write linear here. And then what it is it's saying, I'm going to put an arrow for this one, and it's going to say that it's function. So the second part is this function will become negative x plus 4 if the x is, here it says, if the x is greater than 2, right? If x is greater than 2, then the function here is x minus x plus 4, right? So you see a piecewise function is basically contains 2 or more pieces, and the pieces itself are all functions, but they're all, now we can say that there are exceptions, or not exceptions in this case, but they have intervals in which they are that specific function. So it also contains some type of intervals where that function exists. So in this case, when I talk about intervals, I'm talking about if x is less than or equal to 2, it's this function. If x is greater than 2, then it's this function here. So that's when we talk about intervals. This is the interval. So if x is greater than 2 or x is less than 2. So how do we graph a piecewise function? Now we know about this part. So how do we graph a piecewise function? So I'm going to try to do my best to sketch this out. Unfortunately, I don't have like this, it's hard for me to sketch with using this application. So I'm going to try my best to kind of sketch the graph for you. Unfortunately, I can't use like I said before, I can't use I can't edit the PDF file, so I can't draw on this, unfortunately. But I'm going to try my best to see if I can sketch it for you. So it says here f of x. I'm sketching number 1. Sorry, this is number 1. And I'm sketching for you, this is the piecewise function. This is from what if it's negative 2x minus 1 from x, if x is less than or equal to 2, and if negative x plus 4, if x is greater than 2. So as you can see here, 2 is a defining point in my graph, right? At x equals 2, because that's when the function switches. So I'm going to put here, this is 2, and this is when my function switches, right? So let me graph the left side first. So let me graph like this left side first, and then we graph here, it says negative x minus 1, right? So how do we graph a linear function? It's pretty easy. All we're doing is, we see here, it's our function here is negative 2x minus 1, right? So my y-intercept obviously is at negative 1. So right here, negative 1, I could put a dot here, and then obviously it's gonna, if I do my in algebra 1, if I remember, this negative 2 is my slope, right? So my function is going downwards, and it's going downwards with the slope of 2. So I can say it's moving 2 down and then 1 across. So this would be 1 here. So I'm moving to negative 3, and I'll say negative 3 is like maybe here, and then going down to 1 here, and then from here it's going 2 more down and left, and then that. So if I plotted 3 points, so hopefully that makes it enough for me to kind of graph this. So it intersects between 3 points, and then I can kind of extend this as well towards my upper region. So hopefully that kind of helps here. That's my region here, and there's a point here at 2, right? So if at this point I can actually solve for this this point here, right? I can plug in 2 to my first piecewise function, saying that negative 2 x minus 1. So that's my function, right? 2x minus 1. So if x equals 2, then I can plug in 2 in this x, right? So I go negative 2 times 2 minus 1. Negative 2 times 2 is negative 4 minus 1, which is negative 5, right? So this point here is this is 2, negative 5. And that's a point on my graph here. I could also solve for the X intercepts as well, but you know how to do that already, so I'm not going to do that for you. Again, this is just simply a sketch of the graph, right? But we can do that. We can always just sub it x equals 0 and find what y is, right? So we know how to do that. In this case, it would be minus 1. If x was 0 in this case, I've plugged in x equals 0 here. Negative 2 times 0 is 0. Minus 1 is negative 1. So in this case, if I really want to be really specific here, this is also negative 1 here. So that's my first piecewise function. I'm going to erase this stuff. So that's for if it satisfies this equation here. This is negative 2x minus 1 if x is less than or equal to 2. So that's this part. So now we have a second part here. We have negative x plus 4 if x is greater than 2. So if it's greater than 2, so how would I graph the second part? So first, I would have to find out where does this function start along the y-axis. I know it starts at 2, but I don't know where it starts from in terms of my y, right? So I have to solve for my y first. So how would I do that? Again, I have here, I'm going to do this in blue because this is the second part. So this is negative x plus 4 if x is greater than 2, right? So if it starts at 2, so I have to plug in 2 into this into this equation here, right? So if I plugged in 2, I would get negative 2 plus 4, which would equal 2, right? So at 2, 2, so which means at 2, 2, so at the point 2, 2, this function starts. So at 2, 2, it starts here. So I would have to go to my graph, and it would be, so this is 2 here, so maybe this is 1, and this here is 2. Sorry. This, I'm going to write on my left side. This one, so here's 2. So this is maybe 2, 2 here. And then it's going to do, again, this here, x plus 4. Again, it's just, in this case, I can kind of ignore my y-intercept in this case, because it's not at 0, 0. The function's not at 0, 0. So it's going to start here. You can think of this as my point of origin, and then I'm going to just simply, my slope is negative 1, right? So every time I go down 1, I would go across 1. So this would be 3. So my next point is here. My y-intercept would be obviously at 4 here in this case. Or sorry, my x-intercept is at 4, and then so on and so forth. So in this case, I'm going to get something like, or sorry, I told you I would do this in blue. Sorry about that. Let me, let me do it in blue. Make this point blue as well. And this here would be 3, 3. So this would be 3, 1. This next point would be 4, 0, and then so on, right? So I would have kind of this point, and then it would go like that. So as you can see here, I have 2 of my parts, but I'm missing one thing. You can think of this as a jump discontinuity. We talked about continuity in our previous lesson here. We have a jump discontinuity. And in this case, actually, in this little hole here, this doesn't exist, actually. So let me erase this. And this is actually a hole at 2, 2. And the reason why it's a hole, it's because the function stated that if the piecewise function was x equals 2, I would actually follow this top function here, right? Because it says x is equal to 2, it would follow this function here. It would not follow this top function of x minus x plus 4, right? So I should have a solid point at my at this first function here, stating that at 2, 2, and that's why this point is important, right? At x equals 2, it's 2, 5, and then it does a jump discontinuity to here, which started my my x minus x plus 4 function, and then it continues on. So that's my piecewise function for this one here. I'm gonna see. I don't know if Desmos actually does piecewise functions. I'm gonna maybe I don't think it does. But I'll just graph the 2 functions for you. This is minus 1. And this here would be minus x plus 4. But then I would have to move this somehow to start at 2, 2, right? So this here would have to start at 2, 2, which means I'm going, let's see, I want it to move left. Move left by 2. So I would have to make this, left by 2 would be plus 2. Does that move it? Yeah, and then I have to move. I'm moving it up by 2, right? Up by 2, so this would be 6. Does that work? No, this is still 0, 4. Hold up. I want my y-intercept to be 4, 0. That's fine. But it's not going to. Actually, I don't know. I don't think we can do it actually on Desmos. Unfortunately, I don't know if I can do a piecewise function. Let me leave you with the second question, and then while I search this up, let's look at this problem here first. But this is the answer for my first question here. So this is how you graph this function. I'm going to search on Desmos if I can see if I can do a piecewise function. But if not, we will just continue with my poor sketches of these graphs. So sorry about that. But we'll look at those ones first. Let's do number 2, and we're doing this is this is f of x, and this is a three-part piecewise function. So we have here, this is negative 4 if x is less than or equal to negative 2. We have x minus 2 if it's between negative 2 and 2. Sorry, there's no equal here. And then it's negative 2x plus 4 if x is equal to or is greater or equal to 2. So let's look at these three things and figure out where you would start graphing this function. And I'll draw my graph like this for you and see where I would start graphing this function. Let me just search up, while you think about that, let me just search up if it does piecewise functions. I think it does. Y equals, oh, it does do Desmos. Okay, sweet. So I'm gonna try, let me see if I can do that in other windows so it doesn't bother you. So I'm using the condition first. Okay, so I think I did it. Let me just show you. So pause and think about that first. I'm going to show you what I did on Desmos. And basically, it shows us this graph here, right? And this graph is actually very, very accurate. And what it is I have this piecewise function. I couldn't put the or equal to. I don't know how to do that, actually. So I'd have to put up, I have to figure out how to do this, because this is technically x is less than or equal to 2. I don't know. I don't know if that's equal. No, that makes it negative. Does that make it? No, it doesn't. So I'll leave it. I'll leave it. But we know that this point actually exists here. Right? This here is 2 and 5, and we know that, and it's not undefined because we know it's 2 and 5. I just have to changes to the less than or equal to 2 here. But as you can see from my my poor sketch, it looks very, very similar to what this is, right? Sorry, not this one. It looks very, very similar to this one here. I have a slope line here that goes this way. And then I have another one. It starts from, this point is 2 and 2, 2. This point, well, it's not undefined, but it's 2, 2 technically, because I have this point here, and it's a hole at this point, and that's why it says undefined. And then it's going to go this way as well. So the Desmos kind of gives us a nice approximation. I don't know how to put less than or equal to. If someone's in the chat and can help me out with Desmos, or if you're good with Desmos, let me know. But yeah, that's kind of that the sample for the first one there. So let's look at number 2 now. So I hope you had time to think about number 2. And what we're doing is, again, let's start from the first point here. And I'll do this in black here. So this is -4. The function is -4. So don't be scared of this. There's no x here. So the function will always be -4. So let's kind of make our graph here. So this is -1, -2, -3. So here will be a little -4, right? So this is for -4. If the function is at -2, so let's say this is -2, or if it's less than or equal to -2, right? So 2, 4 would be a point in this graph, and this would just be a horizontal line. It's always going to be -4, right? So this point goes this way, which is cool. So that's the first part of my graph. My second part, it says here x minus 2, so the function is x minus 2. And it's between -2 and 2, right? So I'm going to say this is 1 here. This is 2. So between these 2 points, so between here and here, I should have, I might have x minus 2, right? So let me see if I have a discontinuity at -2 first. So I'm going to plug in x minus 2 for this function here. So this is x minus 2. If I plug in -2 here, I have -2 minus 2. -2 minus 2 is -4. So in this case, it actually picks up where we left off here, because I solved for this point. This point here is -2 and -4, right? So in this case, it actually starts from where we left off here, and it goes towards 2, right? So we can do that. And I think the y-intercept in this case is -2. Yeah, I plug in 0 here. 0 minus 2 is -2. So I'm going to draw this line. I have 3 points. So I'm going to make this line like this, which is awesome. And then I'm going to do my third point. I'm going to erase this, make some space. My third point here is says here negative 2x plus 4 if x is greater or equal to 2. So let me solve for where that starts first again. So I'm solving for x equals 2, right? So negative 2 times 2 plus 4 here. Negative 2 times 2 is negative 4 plus 4 is 0. So my point here is actually 2 and 0, which is great because that's actually here. 2, 0 is here, right? So that's good. We don't have in this case, we don't have a discontinuity, but this function is continuous between these intervals. So let me just erase this. And I'm going to follow the same, again, I can kind of ignore my y-intercept because this here is technically, or not, you can visualize it as that's my 0, 4 in this case. And what I can do is I can just simply use the slope, right? So I'm going down 2, left 1. So this is 3, down, so 1, 2, down 1 is this way. 4 would be down 2, left, right 1. So I have something like that as my function here. So that's going to be my answer for number 2. So I don't know if I can input this in Desmos. I'm pretty sure I can. Input this in Desmos. So let me do that for you. I'm going to input this entire function here. Let's see. This is negative 4. This is x is less than negative 2. Oh, hey, Sven. Yeah, I can slow down a bit in terms of piecewise functions. So sorry about that. I can slow down for you as well. Let's see. I'm just trying to input this into my Desmos, so just so it gives me some sort of function. So that's negative 4 here. I want this to be, this is negative 2 so x is between negative 2 and 2. So my function would be not this, but it would be x minus 2. Sweet. And then I would do a comma, and then from between x, if x is greater than 2, then it's negative 2x plus 4. Is that correct? Is that how I do it? Why doesn't it show anything? Is this supposed to be a comma? If x is greater than 2, there's no equal here. There we go. So again, Desmos shows something weird again, but it's negative. Oh, this is negative. There we go. That's correct. That looks more correct here. So again, as you can see by graph here, my poorly drawn graph, I have here, this is negative 4. So this function is negative 4 when x is less than or equal to negative 2. So that's why it denotes this first, and I use black in this first part, right? This first part here is in black. So I'll color coordinate this for you. This is in black. So this is number 1. It's this section here, right? And I had this restriction. It says here it's between x is less than or equal to 2 is this black part first. And again, it corresponds to this first part here. And then I have the second part is this part here. I'm trying to draw a box around it here. This is my second part. And it corresponds to this part, right? This is x minus 2 between negative 2 and 2, right? So this is this interval is between negative 2 and 2. So between negative 2 and 2 is there. And then in red is my third part, right? It's this last part. If x is less, or if x is equal to 2, or if it's greater than 2, it would be the rest of this graph here. And this is my third part. And this, the interval is if x is greater or equal to 2, greater than or equal to 2. So it's a 3-part piecewise function, and as you can see here, it's all in one color, unfortunately, so I kind of like mine better. But as you can see, we start at negative 4. This is the first part. The second part goes up, so it's x minus 2, so as denoted by this graph. And then afterwards, it goes into negative 2x plus 4. And that's the third part of the graph here. So I hope you kind of understand what a piecewise function, and we'll do a bit more practice with these other ones as well. So maybe we'll work on like 2 or 3 more with these ones before we move on, because this is an important concept because it kind of combines all our knowledge of functions together. So let's do number 3. Number 3 looks a bit hard, but let's do number 3. So this is the piecewise function of, so let's do, this is negative 2 to the power of x. Between x is less than negative 4, And then we have it would be negative the absolute function of x if it was between -4 and 0. And then it's 4 minus x squared if it was greater than 0. So these are my three functions. Again, I have three different parts, right? So I'm going to use three different colors again to show you. So this is my first part here, my second part here, and my third part is here. So let's work on these three parts. Let me draw a graph. Again, I'm going to sketch this graph here. Okay. So my first part states that x is less than -4. So let's say -4 is, actually let me alter my graph a little bit. I'm going to make it more so on the negative side. So it gives us more room here. So this is x, this is y, right? So this here, so let's say this -1, -2, -3, and -4. So -4 would be here. So again, my first part I'm going to do in black, right? So if x is less than -4, I'm going to get this function, -2 to the power of x. So let's calculate that. What is so let's plug in this point, x equals -4, and let's see what value we get. So what is our point here? So if, for example, if y equals -2 to the power of x, and if x was 4, I can sub in 4 into my equation here, right? So it'd be y equals -2 to the power of 4, which would equal, let me take out my calculator. This is -2 to the power of 4. -2 to the power of 4, which would give me, this would give me -16. Does it give me -16? I have x to the power of, oh, sorry, this is -4. My bad. -4. -2, sorry. I inputted it positive. That's my fault. To the power of -4. It gives me 1/16 as my y, which means my y is super small here. So the point would be like literally like here or something like that, like super small. And if you can picture like a exponential function, if you had, for example, this is just an aside, so I'm going to do this here. If you picture y equals 2x, you get something like you get kind of this exponential function, right? So as you can see, if you get -2 to the power of x, it's being flipped in the direction of the it's being flipped along the x-axis. It's being flipped up and down, right? So if, for example, this was -2x, if I did it with y, so if y was -2 to the power of x, this would be flipped downwards, right? So you can see something like this, right? So again, so it's kind of like a, so in this case at 4, it's kind of this part here is what we're talking about here. So it's actually, so this function is going to go something like this here. So it's kind of the trailing part of this function. So I'm gonna do this in, oh, I told you I was doing black, sorry. Do this in black. So it's kind of going like that. And we're not worried about these other values here, because, and I'll show you why we're not worried. For example, if I plugged in a number, let's say for example, this is -5 and -6. Let's plug in -6. If I plugged in -6 into our equation, y equals -2 to the power of x. If it was -6, I would get something like, if I plug this into my calculator to the power of -6, you get something like 1 equals 1/64. It gets even smaller and smaller and smaller. So as you can see, this is just the trail end of our exponential function in this case. So that's why we don't really care about these values here. If you were to be really specific, you could actually input a point and say that, oh yes, this point here is -4 1/16, if you were to be really specific. And Desmos will actually give you that value as well if I plug it into Desmos correctly. So that's the first part. I'm going to switch to blue now. We're doing the second part. So this is negative the absolute value function of x if it's between 4 and 0. So now I have a new point. So between 4 and 0, I'm going to do the negative absolute function of that. So if you recall from our previous video, I'm doing a little aside here. If y equals absolute value function of x, I'm sketching this graph, it would look something like this, right? Like a V shape here, like a V shape, right? If I did the negative of that, I would get something like this. If I get y equals negative absolute function of x, I would flip it along up and down. I would flip it this way, right? Along the x-axis. So I would get something like this. So like an upside down v or something like that. So that's what we're going to get in this part here. So between that, I'm going to get, let's see, so let's plug in our point to see where we start off first. So let's see, let me erase this. Let's just recall as to what kind of function you're going to get. But if x is at -4 in this case, what value of y will I get? So let's plug in, this is y equals negative absolute value of 4, and we're plugging x equals -4, right? So in this case, it would be negative the absolute value of -4. If my negative is in the absolute value, as we learned from the last lesson, or no, as we learned from our previous course, it cancels out that it's negative, right? So I would just simply have negative -4. So it cancels out, it's awkward because the absolute value bar cancels out this negative, but I have a negative on the outside. So it actually still makes a negative here. So this here is -4. So in this case, I'm going to start from -4 and -4, right? My point here is -4 and -4. So I'm going to erase this part here, and let's make some room. Let's make some room on our y-axis. So again, this here would be, let's say 1. This here is 2, 3. Oh, this is negative. -1, -2, -3. Here's -4. So at point -4, it would start off actually here, and then it would make our way to 0, right? So that's kind of our function in this case, because if I plugged in 0 as our point, if I plugged in 0 for x here, so if y equals this function here, if x would equal 0, y would just equal 0, right? The absolute value doesn't make a difference. Absolute value of 0 is still 0, right? So that would be my next point here. So it actually hits the y-axis in this case. So I'm going to draw a line from here to here. So that's my next kind of a point here. So now I have to figure out, okay, is there a discontinuity in this case? There is, right? As you can see, these two, if I plugged in -4 in this equation, I would get -4. If I were to plug in -4 in this piecewise function here, would it follow number 1 or would it follow number 2? So let's think about that for a sec. If I plugged in x equals -4, and you could type in the chat if you want, if I plugged in x equals -4, would it follow my first rule or would it follow my second rule here? Because I'm going to have to change one of these. These two can't be points. So in this case, it would actually go into the second one, and the reason why is because of this sign here. X is between -4 and 0, but it also encompasses -4 and 0, which means this here is not a point. Sorry, this here is, oh no, I don't want to erase that. This here, I'm going to erase this point. I'll redraw it, but I just erased one point here. It's actually going to be a hole here, and it's going to be kind of like that, and it's going to have a jump discontinuity to -4, because this -4 in the second part of the function, the absolute value of x encompasses -4 here. So I'm going to have to use this as this is my point, right? Because if I plugged in -4, I'm going to follow the second rule here. So that's awesome. I have my second part done. So again, my first part was this part. My second part is in blue. So let's work with my last part here. So let me erase this. And my last part states that if x is greater than 0, and again, this is also a point here, right? Because if I plugged in x equals 0, it's going to follow the second one as well, not the third one, right? Because remember, this second function here encompasses -4. It's between -4 and 0, but it also encompasses the point -4 and 0. So it's inclusive of those points. So let's work with this third option here, the third function. So this is y equals 4 minus x squared. So this is a quadratic function, and we're very, very familiar with that already. So y equals 4 minus x squared. So let's first, and we're starting from x equals 0. So let's plug in x equals 0, and let's see if this function is continuous. So x equals 0, I would have y equals 4 minus 0 squared, which this just cancels out, and I'll have y equals 4, which means my point in this case is 0 and 4. So I do not have this function is not continuous because I'm going to start all the way up at 4. So it's going to go, let's make some room here. This is 1, 2, 3, 4. And again, I'm so sorry about my sketch because this is really, really bad sketch. And again, this will be a hole at 4, right? Because if I plugged in a function, if I plugged in a x equals 0 in this case, I'm going to follow the second function here. So in this case, this is another jump discontinuity. It's going to be a hole at -4. And now it's going to just be a parabola, right? I just have a parabola. Because I have here, if you recall from my function here, this is simply y equals 4 minus x squared. If I had y equals x squared in this case, I would get a parabola that opens up. A negative x squared would get a parabola that opens downwards, right? So again, this would open downwards to kind of like, it's going to kind of go this way. Because if you think about the parabola, it's something like this. But I don't have this left part, so I'm going to erase that. I just have kind of this part that goes down here. And we can figure out what the x-intercept is in this case, right? What we can do is we can plug in 0, and we can solve for what our x here is. So let me do that. So we can solve for this point here. So we have y equals 4 minus x squared. And I'm going to plug in if y was 0. So if y is 0, what's my x value? So x here is going to move to the other side. I have -4 equals negative x squared. I can cancel out my minuses here. In this case, I have 4 equals x squared. So x here equals plus or minus 2, right? In this case, it's just 2 because we don't care about this side, right? This -2 here is this function here. So we don't care about that. We only care about +2. So this is 1, which means this is 2. And now this is our function. This is our kind of quadratic. Actually, this kind of extends much more than I thought. So this is actually going to go kind of like this way. It's going to go all the way down. My parabola is really bad, but this is the vertex of my parabola, right? This here and this here in the beginning. So it's going to go something like that without the little thing here. I'm trying to make it nice, but I don't think I can. Something like that. And again, if you looked at, I believe there are answers to this. So let me scroll down. I think there's answers to this. Yeah, there is. So it actually looked very, very similar to my graph here. And this is for number 3, right? As you can see, it's kind of a straight line here. It's not at 1, but it's at negative. This is 1/16, right? So again, this is just a sketch. So this is technically a lot lower. But again, I can only do so much with what I'm given here because I'm just kind of freehanding all this stuff. So this is actually much closer to the x-axis. I have this is the absolute value of x, the little v here in this case, and then I have the parabola that opens downwards. That is kind of my last part. So again, 3 parts to this function. This is that's not what I want to do. I have 3 parts to my function. So again, I have this first part here. Sorry, you can't see that. I have my first part. Let me erase this algebra. We don't need to know this anymore. We just use this to solve for our points, right? So we don't need to know this anymore. Don't need to know this. So here are our 3 parts. Our 3 parts, just to review, was our exponential function was here. So this is between, this is x if it was less than -4. We have the second part, which was our absolute value function. That makes up this part here. If it was between between -4 and 0, and our third part was our parabola, our quadratic equation, if it was greater than 0 here in this case. So this is number 3. That's the third part. This here is the second part, and this here is my first part. So I hope you're a bit more familiar with piecewise functions. Again, this concept is actually very, very hard. And why it's hard is because it's a accumulation of all the transformations we've done in the past and all the functions we can do in the past. For example, I can give you a question that has a quadratic function. I can give you that one has it can be a 5-part piece. It can be a 5-piece piecewise function. I could have something like, a linear, a quadratic, a cubic, a square root, an exponential, a absolute value, and other functions as well, and we can all use that for a piecewise function. So again, that's why this makes this concept a little bit harder, because it's accumulation of all the knowledge that we've been learning about functions in the first place. So I hope you kind of follow along for number 3, and hope I did slow down a bit. I'm so sorry if I'm going a little bit too fast, because there is a lot of material to cover in this course. So I'm hoping that I could get to kind of further along and further more questions, but I will try to slow down just a little bit for the viewers at home as well. So let's do number 4, and I think I'm going to do maybe two more questions, because it does take up a lot of time for us to do, because graphing does take up a lot of time when we talk about when I'm teaching how to graph a function, and I know this is important, so this is a good thing that we're spending time on this as well. So we have here, this is a g of x, so the piecewise function is g of x, and we have it's only a 2-part one, so this is nice. So this is a -6 here is going, so it's the function's -6 if it is less than -2, and it's x plus 1 to the power of 4 if it was x is greater than or equal to 2. So we have 2 parts, so I'm just going to use blue for the first one and red for the second one. So I'm going to draw out my graph. So take some time. How would I approach this question in the first place? What am I going to do first? And how am I going to do it? So let's do that here. And this is my, sorry, the y is not my x. That's not my x. That's my y. Y and x. So let's do that first. And then I'll take a minute to think about this problem, and then let me know in the chat if you have something about that. Oh, these are the answers. So I'm not going to look at. I'm going to go back up actually to this. I'm not going to look at the answers here. So how are we going to approach this problem here? So what we want to do is we want to work with this kind of first part here. Right? I labeled this as the first part, and this is the second part. So let's work in chronological order. So my important numbers are here is x equals -2 is kind of the defining point where my 2 functions split off, right? So let me plot here. So if this is -2, so this would be 1 here, and this is -2. So our function here is -6 if it's at -2, right? If it was less than -2, so if -6 is all the way like super, like it's gonna be like down here or something like that. So maybe I'll have to extend my graph, but we'll see. So let's do 1, 2, 3, 4. It's all negative. Sorry. -5. This is -6. So it would be, my first part would be my function is 2 and -6. So that's going to be a point here, here around. And then if it was less than 6, it's always going. If it's less than -2, it's always going to be 6, right? So it's just a horizontal line heading towards this direction. And I'm going to leave this as a point. Unless actually I don't actually leave this as a point, because this is a hole, right? Because if I look towards my second part of the function here, this encompasses x equals 2. If I subbed in g at 2 in this case, I would not follow the first one. I would not follow this one. I would actually follow the second one here, because this encompasses 2. So in this case, this here is not a point here. Oh no, I erased everything. I don't want to erase everything. I just want to erase the little dot here. There we go. I'm going to make a little hole here. So this is no, that's a bad hole. A hole here. It's kind of a big hole, but it's okay. And I'm going to leave 2 for this function here. So I'm going to work on the second part here. And for me to find out where the discontinuity is, I'm going to have to sub in g at 2 for this function here. So if I said y equals x plus 1 to the power of 4, and I set x to 2, I will get, let's see, 2 plus 1 to the power of 4. And I'm going to get, this is -2, right? -2. This will be -2 plus 1 is -1 to the power of 4, which would equal just simply 1, right? -1 to the power of 4 is 1. So I will have, this is my point, is going to be -2 and at 1. So -2 and 1, which means I may have to make 1 here. So my red point, and this is a point in the graph, is going to start from here. It's going to start from here, and then it's going to do some wacky thing, right? We don't know what we don't really know what a quartic function is. I don't assume you know what a quartic function. I'm going to assume you don't know what it is. So what I'm going to do is I'm going to kind of like logic it out with you. So if I know a parabola, I'll do some black. A parabola is, and this is x squared, right? X squared is this. Now we learned about what a cubic function is in this case as well. This is a cubic function x to the power 3, what would x to the power 4 look like? Well, x to the power 4 actually looks like a lot like an x to the power 2, but it has a little like, it has more curves to it. So what I mean by curves, it does something kind of like, it could do something like this. It looks like a parabola, but with like one extra hump. As you can see here, there's kind of like one extra hump. That's an example of a quartic function, so x to the power 4. So you can think of it as it's very parabola-esque, so it looks like a parabola. So it's going to go kind of like, it's going to go kind of upwards like this, because again, we have a positive x here, right? So it's going to kind of do something like, it's going to kind of do something like that or something like that. It's going to go up, right? Because this is the tail end of this function here. So let me erase this, and I'm going to solve for my points because I want to solve for, I'm going to solve for the where it intercepts y, or where the y-intercept is. So let me erase this. Let me scroll, let me put this down. So if I have the function, I have a function here. This is y equals x plus 1 to the power 4. If I want to find my y-intercept, what would I sub in? I would sub in x equals 0, right? So if x equals 0, then I have y equals 0 plus 1 to the power 4. 0 plus 1 is 1 to the power 4, which equals simply just 1, right? So my point here would be, this would be 0 and 1. Right, 0 and 1. So 0 and 1 would be a point in my graph. And as you kind of remember, so again, I have here, and I can also solve for my actually x-intercept, right? So let me solve for that as well. So I'm going to do that maybe here. So this is y equals, oops, sorry. So if I want to solve for my x-intercept, I'm subbing y as 0, right? So if y equals x plus 1 to the power 4, I'm subbing y as 0 in this case. So this is equals 0, x plus 1 to the power 4. How I would get rid of the exponent in this case, I would take the fourth root of both sides. The fourth root of 0 is still 0, so it doesn't matter. So this kind of just gets rid of that. So x plus 1, in this case, x would equal, move 1 to the other side, would be negative 1, right? So negative 1 would be my my intercept, or yeah, this would be my negative 1 and 0 would be my intercept here. So negative 1 and 0 would be my x-intercept. So I have a point here. And now what we can do is we can actually just connect these 3 points together, right? So it would have my parabola looking like this, and this would kind of go all the way up, right? If it was on the left side here, it would actually kind of be a parabola-esque, but this left side is removed, right? Because my function doesn't exist on this left side. My function is -6 on this, right? On this side, right? So that's gonna be my answer for number 4 here, and I'm gonna break down how we break down the different parts again for you. So again, this part here is if x is part 1. Right, part 1 here, and I stated that part 1 here is -6 if it was between x, but not if it was less than -2, right? So if negative x, if x is less, if x is less than -2, and then this red part here, so this part here was number 2, right? This part is 2, and it follows this satisfies this function here, right? So x plus 1 to the power 4 if x is greater or equal to 2, and that's going to be my function here as well. So again, I have two pieces to this function here. So I hope, and then I can actually check my answer with, because I can, and again, this is correct. It looks very, very similar to what this is. And again, I have my point here, point here, point here, and then I also have my point here. So we're good for this function as well. Let me do one more. I think we have time for one more. So let me do kind of a nasty one for you. Let's do 7. Let's do 7. And we'll call it a day. Let's do 7 and we'll call it a day. And hopefully I finish. So this is w of x is this is the piecewise function, and there's 3 parts. We have absolute value of x over 2. If it was x is less than or equal to -4, we have the square root of -x. If it was between -4 and 2, and then we have the absolute value of x minus 2 if it was x is greater than or equal to 2. So again, we have 3 parts, and I'm going to label them as well. So again, the first part's in black, so it's 1, in blue would be 2. And then my third part would be 3, right? So that's fine. And then I'm going to draw my I'm going to poorly sketch my graph again. And let's hope that I'm pretty neat with this. So this is x and my y. So again, I'm going to look at my intervals first, right? My first interval says that x is less than or equal to -4. So let me find -4 first. So this is -1. So it'd be -2, -3. Assuming here is -4, right? So -4 would be here. And it's going to be the function, again, I have this function here. It's going to be the absolute value bar of x, or absolute value of x, over 2 equals, it's going to be if x is less than -4, right? So again, if you think about my absolute value, it's going to be my little v, right? So for example, if this was this, I'm going to have my kind of v function here, right? The absolute value bar of x is this v function, right? So you can say that I have kind of a v looking shape, like looking shape here. So let me sub in -4 and let's see what point we start at. So if I had y equals absolute value of x over 2, and I'm subbing here x is equal to -4, right? So let's see where my y is. So it'd be absolute value bar of 4 over 2. It's going to cancel out the negatives here, so 4 over 2, which equals 2, right? So I'm going to have, this is going to be the point -4 and 2. So -4, so let's do 1, 2. So this will be my point. It's going to go like this, and then it's going to kind of go, it's the v, right? So it's going to kind of go this way, because this way. Sorry. It's going to go basically, because it doesn't go up like the slope of this one is actually half of the initial slope. So -5 won't have a point, but -6 will have a point. -6 will go up by 1, right? So in this case, it would be, my next point is kind of like here, because my slope is half, right? So it's not 1. If it was 1, my point would be here, but it's a half. So it's actually, I'm going to move 2, shift 2, and then go up by 1 instead. So this function will look something like that. I hope I crossed the point. Look, I don't have a ruler. Like that. Okay, that's fine. That's my first part. Let's do my second part here. The second part I'm going to do in blue. And it's going to be a square root function of -x if it's between -4 and -2, right? So it's between those 2 points. So let me sub in -4 and let's see where we start. So let's see if my y equals -x at x equals -4. It's simply going to be negative minus 4, this will cancel out to +4. So positive root 4 is 2, right? So I have my point here would be -4 and 2, which means this function is actually continuous. So it's going to start from here. And then I'm going to picture, what does the square root function look like? Oh, sorry. And this is where transformation comes into play, right? Again, if I sketch my square root function, it looks something like this, right? If y equals root x, looks something like that. What about if y equals root of -x? My reflection is not going to be left down. It's going to be side to side, right? So it's actually going to go this way instead. So that's going to be my function going that way. So it's going to look something like that between -4 and 2, actually. So let me plot these other points here. So this is 0, this is 1, and this is 2. So let me sub in more points. Let me sub in more points here to figure out what it wants. So let me sub in the point -1 here. So if x here is -1, it's gonna satisfy my second equation, second function here. So if y equals, this is -x, if it was x equals -1, then I'll have y equals square root of negative, negative 1, minus, minus 1, right? These negatives cancel out. I have root 1, which is 1, right? Which means my next point would be at the x is negative 1 and 1, right? So negative 1 and 1 would be my next point here. Next point here. And then if I subbed in 0, obviously the square root of 0 is 0, right? So my next point could be here as well. So I have 3 points now, and I can connect those 3 points together. But let's sub in x equals 2, because that's my boundary as well, right? X equals 2. So what happens if I sub in an x equals 2? So if y equals the square root of negative x, if x is positive 2, I would get the square root of negative 2. And this would actually give us an error on our calculator, because this is not a real number. This here is a complex number. We're going to talk about complex numbers more in a later video. But for now, in the real plane or in our graph, it means it doesn't exist. So anything that passes or goes into positive, anything that's greater than 0 does not exist. So there's actually a hole, well, not even a hole, there's actually a big gap between 0 and 2. So I can only plot from 0 to negative 4 in this case. So I'm going to have something like this as my graph, which is the second part. And I'm just going to leave from 1 to 2. From 1 to 2, there's not going to be anything. I'm going to just leave the gap. I'm going to leave a gap between 1 and 2 here. There's going to be a big gap here. And then I'm going to work on my third function here. This is the last part. I'm going to plot some more points here. I'm doing red for you, as like I said before. And this is the function, the absolute function of x minus 2, right? And let's see where it starts at 2. If I plugged in x equals 2, what is my y value, right? So if y equals the 2 minus 2 in this case, I'm plugging in 2 for this x. I'm going to get 2 minus 2 is 0. Absolute of 0 is still 0, right? So my point here is 2 and 0, which means I'm going to start at 2, 0. So just like right here. And this is actually a point in the graph, because if I subbed in x equals 2, or if I subbed in the w at 2, it would follow not this function here, but this function here, because this is inclusive of 2, right? I see this equals to 2, right? So that's okay. And this is simply just a absolute function now, right? So I can go, it's simply just a linear line going straight up this way, right? So I can say that this next point here is 3, and then 3 and 3, 1. The next one here would be 4, 2. The next one is 5, 3, and so on and so forth. So I'm going to have a line that goes like this. So let's check my answers here. And again, I have a little gap here, right? So let me check my answer to see if I got this right. And I did, right? I have, this is number 7 here. I have this, it's kind of hard to see because this is a line here, and then a square root function here, and then my, and then the absolute function here. So let me break that down for you, and we'll call it a day after this. But here, if you look at this function here, again, this here is my number 1. This here is my function 1, and that was what we wrote here. The absolute function of x divided by 2 is here, and it's between. It's gonna be less if x is less than or equal to negative 4, right? Is this function here? X is this function here, right? X, the absolute value of x divided by 2 is number 1. Number 2 would be my square root function, right? I did a square root function. Actually, it actually encompasses the gap as well. So this is number 2, and this is this negative x between negative 4 and 2, right? That's this function here. As you can see, there's a square root function here, and there's a gap here, right? Because if I plugged in a positive number in this function, it does not exist in this gap. So there's a little gap here as well. So again, you can see the reflection along the y-axis. It's like a square root function here, and my absolute function here. And then my third one is another absolute function, right? I have the absolute function of x minus 2. And this is if x is greater or equal to positive 2, and that's I get this y value here. So I hope you kind of got this concept of piecewise functions. Again, piecewise functions are a lot, and just because, like I said before, it's accumulation between all the functions we've learned, including its transformation. So it's a lot harder for us to plot in this case. So what we're doing, again, we're chunking this down to like three different parts. For example, I focused on the first function first, then the second function, and the third function. And then with those points, I'm solving for what? X-intercepts, I'm solving for Y-intercepts, I'm solving for where this interval ends. So specifically, I'm solving x equals -4 for this function. Where would my point be on Y? I'm solving for at -4, where is this point here? At 2, where is this point here? At 2, where is this point here, right? So I'm solving for all these points, and then I'm simply just plotting the graph. So that's going to be my lesson for today for piecewise functions. I hope you kind of dealt with my little messy sketches of my graphs here, but that's kind of how you would solve for these functions here. I hope the color really helped, because I think the color helps for me when I'm talking about piecewise functions, and I didn't really like the answers because the answers kind of all just gave you in red. So I'm kind of happy that I got the color in, so it shows you that how a piecewise function is divided between parts depending on what intervals they are. So for next lesson, what we're going to do is we're going to start on this topic of function operations, and then we're going to move on from that topic. So as always, thank you for watching. Stay safe, stay healthy, and I hope to see you in the next video. So take care.